Hello, we have solved some rational inequations in our last session. I'm sure by solving 3 or 4 inequations, you must not have got that confidence also. So obviously we need little more practice. So this session we will have more inequations, but they may not be exactly on similar lines what we had before, but maybe some more variety I should say. So let us start with some more examples. Question says that x minus 1 whole square into x plus 1 upon x cube into x minus 2 is less than 0. This is our given inequation. And question is regarding the statement which is not true. So be careful while answering the question. So there could be one or even more statements which are not true. Those 4 options are given in the form of statements. They are not mathematical expressions like what we have used for solution set, etc. Now I start with x minus 1 whole square into x plus 1 upon x cube into x minus 2 less than 0, the given inequation. This is perfectly in the form of Rx less than 0, so no more changes required. Numerator is x minus 1 whole square, denominator is x plus 1. Critical points we know, they are 1 and minus 1. And denominator's critical point would be x equal to 0 and x equal to 2. Inequation is a strict inequation. So critical points will not be in the solution set. So x equal to 1, minus 1, 0 and 2, they will not be in the solution set. So x not equal to these 4 values. My next step should be that I start solving. But I realize that x minus 1 whole square is a positive quantity and it becomes 0 only at x equal to 1. Otherwise, it has no role to play. So why to continue with that x minus 1 whole square? Why to retain that factor x minus 1 whole square? So I would try to drop that x minus 1 whole square because it has no role as such in fixing sign, whether less than 0 or greater than 0, because it's itself is positive. We are just multiplying by a positive quantity. Now, denominator has x cube in it. Again, I take that x cube as x square into x, and then I will say that x square is not required because it is positive. And I write a simpler inequation as x plus 1 upon x into x minus 2 less than 0. Now look at the given inequation and the inequation number 3. Now inequation number 3 seems to be much easier, much simpler than the given one. But we cannot forget that x is not 1, x is not minus 1, 0 and 2. So I would say solving 1 is same as solving with equation 2 or the values given x not equal to so and so. You have to remember that. Recall interval method. How did we do? We plotted minus 1, 0, 2, that we'll have to do, and then I will have to see where does the solution lie. Critical points are minus 1, 0, 2. So I mark them and I find the solution. I realize by method of intervals that minus infinity to minus 1, 0 to 2 will participate in the solution set. But solution set of what? Of given inequation? No. They will participate in solution of inequation given in 3. We have to still attach that x not equal to 1, not equal to minus 1, not equal to 0, not equal to 2. So when I do that, I realize that x equal to 1 is actually in that 0 to 2. That will have to be discarded. That is not to be considered. So I would drop that and I will write my solution set as minus infinity to minus 1, union 0 to 1, 1 to 2. Now I am ready with now my solution set. Now I just look at those 4 options. First option is 4 consecutive integers do not satisfy the inequation. Now when I look at the solution set, I realize minus 1 is not taken, 0 is also dropped, 1 is also dropped, and 2 is also dropped from the solution set. So 4 consecutive integers do not satisfy is a correct statement. Then I look at the second statement. There is no positive integer solution. Look at the solution set. We have 0 to 1 open interval, means 1 is not included. Then I have union 1 to 2. Again 1 not included, 2 not included, means no positive integer in the solution set. So statement B is also correct. the greatest negative integer solution is x equal to -2. We have minus infinity to -1 and -1 not included. So the greatest negative integer is -2. So C is also correct. Then by default, D is not correct. But still, let us check once, compare with our solution set and the solution set given in D option. Obviously, they do not match. So option D is wrong. Now, this is little different from what we had done before. I mean, at least from that options point of view. So I discussed with you. Then I go to next. Next is absolute value of x plus absolute value of x upon x minus 1 equal to absolute value of x square upon x minus 1 and x not equal to 0 given. Then we have to select the right option. Means we have to select which x will satisfy the given equation. Equation actually is in the form of absolute value. Now again, it looks as if question is from absolute value and what is it doing in rational inequations portion. Realize this, all topics are that way interconnected. From one part to other part, you should be able to switch over. I start with given equation and I notice that if I take in place of x as a and in place of x upon x minus 1 as b, and if I go for a plus b, I find it is nothing but x square upon x minus 1. And on the right hand side, in the absolute value inside, it is given as x square upon x minus 1 only. So given equation is actually of the form absolute value of a plus absolute value of b equal to absolute value of a plus b. We have done triangle inequality. And in triangle inequality, we have seen that absolute value of a plus absolute value of b is greater or equal to absolute value of a plus b. Means equality has occurred here in the triangle inequality. When does that happen? Recall, that comes when AB is greater or equal to 0. Means A or B, even one of them 0 or both are 0. Now x not equal to 0 is already given to us. X minus 1 appears in the denominator. So x equal to 1 cannot happen. So realize this, that we have only option as x into x minus 1 should be strictly greater than 0. And now I realize that it is x square upon x minus 1 greater than 0. Numerator is already positive, which is x square. Denominator has in it x minus 1. Now that will have to be positive to get x square upon x minus 1 greater than 0. So my option is x greater than 1. And that appears as option A, and that is the right option. Now we have done some simple questions, little better questions also from rational inequations. Some in case of equations also we have found them. So realize this, that if you practice more, you will have, again, as I said before, you will have grip on the topic, and please keep practicing. Stay tuned till I come with the next session. Thank you.